Okay, let's get going. So next up, we have Paul Smith. But before I introduce him, I would just like to say that we are doing GOTO nights in Stockholm 4 times this year. Next up is going to be in April, where we're going to talk about modern front-end development, and it's titled Post JavaScript. So the sites for registration is going to be up tonight. So please go and register if you're interested, and tell all your friends. Also, we have GOTO Copenhagen coming up, a big, cool conference. I urge you all to attend. It's coming up in October. And for those of you who fill out our survey that we're going to send out in the coming days, we will raffle off a ticket for a 3-day pass. So go do that. Once you leave tonight, you can pick up a goodie bag outside. And now let's continue with a story about fraud and how it could be avoided using modern technology.
Thanks, Thomas. That working okay? Hi everyone, welcome back. I hope you're suitably refreshed. Yeah, I'm going to tell you about a fraud case I investigated around 10 years ago. It's a European-based fraud, and go into these 2 technologies that we prefer. We do use multiple because not one piece of software will solve all your data problems. Just a bit about myself. I spent 24 years in financial services, all around risk. I did originally start out as a programmer back in the early 90s, but then very quickly moved into the fraud area. I was lucky enough to be a fraud investigator for 8 years, investigating frauds throughout Europe as an independent expert. I now work for Trifork Selected, which is part of the Trifork group. We specialize in business consultancy. We've got a whole bunch of techies worldwide who are specialists in all the products that we use. First of all, anti-money laundering is a big area now. The new EU directive, if you're not aware, is coming in July the 1st, and it's quite a scare story, really. There's not many businesses that are ready for it. The guidelines that they give from the EU legislation is very fluffy. It gives very simple examples. There's lots of increase in the penalties. So now there's prison sentences for chief risk officers as of July, up to 14 years. The payments have been brought down from €15,000 to 1,000, which just means a huge volume of data and increase in that data over that period. And they've introduced connected payments, but they don't say how long the connections are. So that could be €100 for the next 10 months, and that's a connected payment. It's how they interpret it. So we use technologies to try and prove due diligence as part of that anti-money laundering activity. This particular case we're talking about, which is back in the past when I was an investigator, it was committed in Europe. It's quite a significant value for the region, and hence that's why I got brought in to review the case. Initially, it was 10 loans identified that was involved with a fraud, and I arrived and thought this is going to be really boring, but within a few days, it just blew out of all proportion, and it was actually a money laundering case and made it very interesting. So this particular company, who I'm not going to name for obvious reasons, they have this process of doing welcome calls when you have new customers and new loans. They have regionalised offices, and when admin staff have downtime, they was making these calls rather than it being a dedicated call centre. So there was just a handful of staff doing these calls. And the fraud was actually found when one of these admin staff realised the same numbers were coming up again and again. And there was always going to voicemail. So she started reporting that, and then when an investigation happened, they found the first 10 frauds, which was still significant. So I went out and did lots of interviews with lots of internal staff. We had a whole raft of procedures in place to stop fraud happening. But there's lots of breaches in those procedures by staff because it was a very manual process in terms of detection and prevention. We had a separate security team. They missed all the signs and didn't actually find the fraud. So it was actually found by operational staff doing these calls. And after a few days, I actually used graph theory, but in SQL environment. I had a team working for me back in the day who were all data scientists, and I got them in SQL to join all these potential customers from the fraud together, which took them a number of days to do, but it was invaluable because it helped me understand that 90% of the loans taken by these brokers were involved with this fraud, not just 10 loans. And then there was a revelation after a week that actually there was 2 corrupt police officers involved. And what was happening, allegedly, because we never proved it because there was an internal police investigation going on, so they never confirmed it to us. But there was allegations they were running racketeering and unauthorised gambling, and they were legitimising those funds by using these brokers to take out loans. And then what they would do is those loans would be passed to their accounts under different personas. So it looked like they were getting money from different people and payments from different people. In reality, all that money went back into making the loan payments, so nobody visited because of bad debt. Everything was 100% right. Nobody made any phone calls. The security team, as a consequence, didn't visit. So once we interviewed the brokers, they verified that pretty much everything they'd done for the last 12 months was part of this deception, this fraud. So yeah, it went on for 12 months. Because it was the brokers, they knew the checks and balances in the systems. And that enabled them to bypass all those checks and balances and those procedures, which allowed the fraud to happen. They got found out because they started getting lazy. They was buying multiple SIM cards and individual numbers to begin with for the first 6 or 7 months. But then they started reusing those SIMs. Now, they didn't have a phone for every single SIM that they bought and every loan that was taken. So they were putting the SIM into the phone every few days. There'd be a voicemail left for that welcome call, and then they'd ring back and say, I'm such a body, under the false details that the loan was taken out on. And that's why the admin staff started to realise it was the same numbers, because it was constantly going to voicemail and they had to dial it a number of times before somebody would ring back and say it was person X who'd take this fraudulent loan. At the time, that particular company had some quite legacy systems in place. One of the main ones was logistic regression, but logistic regression is not great for fraud because you don't always know all your outcomes. In my personal experience, I've never seen a good logistic regression algorithm that's good at tracking fraud or risk. We also had some high-risk models that was tracking basically the high growth and value. Now, these models actually flagged it up, but the security guys weren't doing the job. They had such aggressive targets that they weren't able to do the job. But these reports were highlighting that there was a potential problem here. And we had some experts based centrally in each of the countries, but there was only 2 of them in this occasion in this country, and they just overloaded with work. But they were the real specialists. They would have found it, but they just had too much work to do on checking the rest of the country. So these are the technologies that we typically use for combating AML fraud. We also use them for recommendation engines as well. So we have the data element, which is Elastic, Humino, and React, all NoSQL technologies, schemaless if you want it to be. So it's great for adding things in when you don't know what you want in terms of data, because you only find things out when you start analyzing it and doing champion challenges. So we also use Neo4j and Spark. Again, data stores in their own right, but have different functionality. Spark we use for deep learning algorithms. Neo4j we use for graph databases. And then we use TensorFlow, Python, Scikit, and Theano for building deep learning algorithms. we've got guys in the company a lot cleverer at me building those algorithms. The first talk we had, I actually agreed with everything that was being said there in terms of doing those algorithms. It's a very, very unique skill in making those algorithms work. But everybody at the moment loves talking about machine learning and deep learning. So I'm going to focus on two today, and that's Humio and Neo. And the next talk's actually on Humio, but it's more of a deeper dive than I'm doing. I'm just keeping it very high level and how we use Humio. So Humio, reporting and analytics databases. It's great for DevOps, data management, performance management. It does a multitude of things. It's great at fast ingestion, particularly of logs. The two that I'm always interested in, because it's my background, it's where my expertise is around reporting and analytics and analytical databases. And what we use Humio for that is the backbone for running our deep learning algorithms, because it can ingest data so quickly. And you've got to have fast technologies behind these algorithms, otherwise your online process will just grind to a halt, and you're then going to lose customers as a consequence. And the term big data that everybody loves or hates, the best description of big data I ever heard, it's big data is like teenage sex. Everybody says they're doing it, but nobody actually is. So the number of companies that, yeah, we do big data. What's big? More data than yesterday? The great thing about Humio is that it can ingest these IT logs, but most people think IT logs are just for IT people and for monitoring performance. But there's real value in the data in there, and that's what I class the big data, new, innovative data. And because we can get these IT logs in very quickly, we can also pinpoint and extract the data that's important from a risk perspective, or it could be a recommendation, fraud, AML, multitude of uses for the business, not necessarily just for IT. And it can hold a hell of a lot of information. So every single data scientist I've ever worked with, they always want all the data forever, and they hate deleting data. But with technologies like Humio, you can do that, and you can still search on it really fast as well. So in terms of deep learning, and we've already had a talk on deep learning. The real game changer was in 2008 when there was a new way of traversing the trees in deep learning. Some very clever academics changed the way it works in terms of speed. Then all these great community open source products came along and got released into the general environment, so you don't have to write them from scratch yourself. So Spark in 2013, TensorFlow in January last year. So it's great news that all these products are there, so you can actually make deep learning more of a commodity in terms of into your business. But commodity hardware as well is really important because it does take a lot of processing power. So the fact that hardware is coming down in cost really helps in achieving those deep learning algorithms and the implementations. So we use Humio as the data store pretty much for those deep learning algorithms with many clients. And like I say, you can access a huge amount of history because you never know what you want tomorrow. You've got to choose your features carefully, as has been said before. You don't know if those features are right or not. You need access to the whole history or the whole data set so you can pick and choose your features once you've done your A/B testing on it. If I would have had this when I investigated that fraud, I guarantee if I wouldn't run these algorithms, it would have found that fraud. Absolutely guarantee it. But at the time, we was using SQL. It was slow, horrific. We were going to lose customers if we were putting algorithms in. And to be honest, the actual methodology hadn't come on that far. I was using AI back in 1995, and we ditched that project because we just couldn't get it into that process fast enough so that we were doing the conversions for customers and selling those loans. So it's not really anything new. It's just got better, a lot better. So moving on to Neo. Again, if we would have had Neo, it would have found this fraud. Neo's a fantastic tool for analyzing connections. In the background, it's a specific graph database. So it's almost, if any of you have ever seen or heard about network databases of old, 2-3 decades ago, it is a network database. And because it has all its connections stored, it's really, really fast. in terms of searching that data, finding those complex connections. When I had the team do it in SQL, it took days. With Neo, it would have took minutes to do exactly the same analysis. And the great thing is, Neo you can use in an online environment as well as offline for investigation use, or for doing your, for your analysts to look for new things to look for, to plug into your online process. It's got a great visualization behind it to do that. So, very quick explanation of graph theory. Graph theory itself, which is graph databases are built on that, is 400 years old, so it's not a new methodology. A Swiss mathematician originally created it for a problem for crossing, only going down all the streets in Königsberg in Prussia. That's easy for me to say. And basically the emperor wanted to go around and only visit every street once, and the mathematician created the theory to work out if it was possible, and it turned out it wasn't. But it's all about edges and connections. That's what graph theory is. So in this very, very simple example, you've got a number of customers, for instance, person A, B, and C. They're all intrinsically linked. We're somehow or linked. We're linked from tonight. We have connections. You have connections everywhere. And in the case of this simple example, there is a connection with a shared address and a shared phone number. So that just means that, very simply, you can make a link between person A and B. On a slightly more complex one, but again, still very simple, you've got connections between phone numbers, addresses. This is actually what happened on the fraud case I just talked about. So they started using the SIMs, the phone numbers for the SIMs, as the nearest relative, because you had to give almost a reference. And that's why we saw all the connections, and we realized that the fraud ring had grown to 90% of all the loans issued. But using Neo, you can very easily, in an online environment, run queries to work out the shortest connection between people or things or products or whatever thing you want to search for. So once he found that first fraud on person A, as an investigator with a visualization tool, which looks like that, only a bit nicer, with bubbles, I can drill into it, I can move things around, I can dig into the data, find new connections and find new things. So you prioritize your investigations on that. In the same way, it can be used for recommendations. So there are several online retailers who use Neo and graph theory to make recommendations instantly when customers are buying things. We have an online gambling client who uses it for making in-game recommendations within 20 milliseconds. So as soon as you start playing a game, instantly you've got, I'm playing this game, who else has played the game? What demographics did he share with me? What have I played that they've played? And you can look at the entire user base and work out whatever he's played, recommend it, and they're more likely to make more money because they're going to recommend that game. And Neo does that really quickly. So it is our recommended tool, certainly to start with, for fraud and AML, because it's black and white, it's easy to understand. A lot of senior people in a lot of the companies, particularly financial services, don't like deep learning because they can't understand why it's making the decisions. With Neo, you can see it black and white. Simple as that. As I say, it's brilliant visualization. It's for the business user, not the IT department. And it's great for online real detection or recommendations. But as I started out, all these things can't always be solved by one product. You've got to have a toolkit, particularly around fraud and AML. So this will find an element of it, but you should be doing other things in the basics as well. Hope that was interesting, and thank you for your time.
Okay, so do we have any questions? Over here. Oh, let me just grab the box here. There you go.
Thank you. I have just one doubt on your presentation in the Neo 4G. This case of network analysis, this one problem is that if one node is more dominant, like you have more dominant structure, then it will be biased, give biased information. And then you go to the second, this fraud analysis, you could be more biased. So the challenge is how you do it first fraud analysis and how to overcome it in these kinds of places.
Yeah, you're absolutely right. As part of the query, though, it's not just about making the connections. Part of the query language, you can say what not to look for as well, as part of a complex query. So you can rule out some of those elements that you know. But there's also a concept called the magic number in Neo. So if things are too common, it will ignore them. So there's always a great example from Neo where they analyze public data on music tastes. And whether you like pop music or whether you like classical music predominantly, everybody likes Coldplay. So you have to rule out Coldplay.
Yeah.
And the way you do that is a magic number. It's just too many connections into that from everybody in your data set. And that's how you deal with it.
There was a question up here as well. No? Okay. Good. Here? Yes?
Thank you. So you have shown a great example how these tools that we have today could have been a game changer with your case 10 years ago. Do you see any problem areas that are similar today that might be difficult to solve now with fraud detection and that might need some work or some tools?
So the biggest problem today is with the advancement of online financial services, you've got a real neat way as a fraudster to hide things and commit money laundering as a consequence. Because you can send things out the country really easily and back in again between organisations within minutes in most cases. As part of the new EU directive, there was talking about a public database for all transactions across the EU. That's just not going to happen because it's too big and it's got to be government funded and it just won't happen by July. So they're still talking about it, but it won't happen. But that's probably the biggest challenge in terms of fraud and money laundering that financial services are facing today.
Any further questions? Okay, good.